Okay, in this video I'm going to show you how to graph and describe the characteristics of root functions. Basically square root, cube root, or any kind of any root value. So the most basic function is, and that's what we always start with, is the square root. Start with square root of x. And this is a basic function, a parent function. So if we really get really good at graphing this and describing its characteristics, then everything else is just a translation, a transformation from there. Alright, so square root of x, I'm going to pick values for x. I'm going to pick, my first value for x I'm going to pick is x equals 0. So the square root of 0 is 0. So when I substitute x, I get y equals 0. So my first point on my graph is going to be at the origin 0, 0. Alright, now next point I'm going to plug in is positive 1. Alright, the square root of a positive 1 is 1. Square root of 1 is 1. Alright, so when I plug in 1, I get an answer of 1. So I also have a point at 1, positive 1, positive 1, which is be right there. Alright, now I'm going to skip 2 and 3, even though we can approximate square root of 2, square root of 3. They'll be irrational rational numbers, and it's just not as convenient to graph, but they do have answers. So when we talk about range, keep that in mind. So next number I'm going to substitute for x is positive 4. Alright, the square root of 4, and by the way, if you don't, the basic definition of a square root means we have to have two numbers that are exactly the same that will multiply to equal that number inside the radical, called the radicand. Alright, well, what two exactly same numbers would you multiply to make a 4? Well, 2 and 2. Therefore, the square root of 4 is a 2. We already knew that, but just in case. So when I substitute in 4, I get an answer of 2. So on the x-axis, go to write 4, and the y-axis go up 2. So there's another point. And I have room for one more point. So I'm going to substitute my next number I'll use for my x is 9. The square root of 9 is 3. The square root of 9 is 3. So I substitute in 9 and I get an answer 3. So I have another point there. Now, an issue with square root, not really an issue, but just a characteristic of the square root function is we don't allow square roots of negative numbers. Okay, so I'm not allowed, when I'm doing a graph, a real number graph, to substitute negatives. So we do have, when we work with complex numbers, square root of -1, as you recall, that's I. And so if we did change the y-axis to an I-axis, we could actually graph with a negative, but we're not going to do that. We're just going to stick with real numbers. So I'm not allowed to substitute -1 or -2 or -3. So that's it. This is my graph. This is part of my graph. So my graph of the square root of x go like this. Alright, therefore the domain is restricted. This is the first, if you've been going through my videos, this is the first type of function that has a restriction on its domain. Okay, we don't plug in any negative numbers, so the lowest number I can plug in is 0. So I'm going to put a 0 and I put a bracket there because I actually substituted in 0. I didn't substitute a number greater than 0 or just bigger than 0. I substituted actually 0 in and got an answer. Alright, I substitute positive 1, positive 4, positive 9. I could substitute positive 16 and all those numbers in between. So I could substitute any positive number. So the my domain is anything larger than 0, including 0. Alright, what's the range? What do the answers look like? My first answer, when I plugged in 0, I got an answer of 0. I substituted, got an answer of 1. When I substituted 4, I got an answer of 2. When I substituted 9, I got an answer of 3. And we can get an answer of 4 if we plug in 16. So we can get any answer as long as it's 0 or above. So the range looks exactly like the domain, but it represents different answers. The range represents y values or answers. And of course the domain, that represent the x values we could use, okay, or the input. Okay, the interval of increase. Okay, this is I think I erased one. Okay, the interval of increase, kind of interesting. Okay, and so I put my little person at 0, at x equals 0, and make him walk to the head. So it looks like starting at 0, and then at x equal 1, and x equal 4. Remember, always go back to the x-axis, not the y-axis. X equal 9. It's increasing. So I'm going to put 0, and I'm going to put infinity. But this is really kind of interesting at x equals 0. Do I put a bracket there, or do I put a parenthesis there? And really, to really understand what I'd put there, you'd have to really know calculus, which I'll show you really quickly. And you can ignore that if you're not taking calculus right now. But y prime is actually the derivative of the function y equal x. And the derivative actually turns out to be 1 over 2 square root of x. And when I substitute in 0 right there, I get a 0 in the denominator, which means the slope of that function at that point, the derivative stands for a slope, which you'll learn when you take calculus. The slope is undefined, which means that the slope at that particular point at 0 is a vertical line. Doesn't look like looking at this graph, but if you were to zoom in, let me see if I can find a blank sheet. Okay, so if you could actually zoom in, I mean, let's say here's 1 way over here, and here's 0, and here's 1 way up here. Alright, and here's kind of that area. Okay, the slope right here and the slope right here, they're positive, and there's a slope right here. The closer you get to 0, the slope, these are called little tangent lines. The closer it gets, it's the straight up and line, and the straight up and down line, has a slope that's undefined. Okay, so long story short, is pretty interesting. The slope at actually 0 is undefined, so I cannot use a bracket there. Use a parenthesis. Okay, so long story short, interval of increase is 0 to infinity. Now, as you go to the right, the rest of it's not hard to understand. It's never going to go down as we go to the right. None. The x-intercept, x-axis at 0, it touches the x-axis at 0. The y-intercept touches the y-axis at 0. The right-hand behavior, what is the graph doing as we go to the right? It sweeps up. Okay, it sweeps up. So our answer is, as x approaches positive infinity, y approaches positive infinity. Now, this is the first time, I believe, that we don't have a left-hand behavior, because this graph is never going to left forever. It stops right there at x equals 0. Okay, so a left end and a right end are talking about what happens eventually as it continues to go forever to the left. It never goes to the left. So it doesn't have really a left end. You could say maybe the left end is this point right here at the very end of the, going left. And maybe you could argue that, well, the y value for that is 0, so I'll say 0, but I'll put down none because it really doesn't go to left forever. That kind of defeats the purpose of investigating a left end or right end behavior. So I'm going to put none. Okay, my next example is I'm going to start with the basic function, the parent function. Alright, I'm going to write, this time I'm going to include a +3 underneath the radical sign. Well, the radical sign is a grouping symbol. Mainly we think about parentheses as grouping symbols, or brackets, or even braces in some cases, grouping symbols. But also a radical sign is a grouping symbol. The fraction line, like we have a 1 over let's say an x plus 3, the fraction line is a grouping symbol. The absolute value signs, that is a grouping symbol. So the point of all that information is that there's a +3 grouped with the x, and that means when you have a number that's grouped with x, that means it's a shift of left or right. Shift left or right. When you have an x with a number like a +3 or a -3 or some situation like that. Alright, so the +3 actually means we shift left. So trying to speed up a little bit, let's do a basic square root of x. Alright, which we did on the last example. All we need to do is shift those 4 points, 3 points to the left. So this, you have a point there. The point at 1, 1 would shift to the left, be right there. The point at 4, 1 would shift over 3, be right there. The last point would be right there. So the blue graph, the blue points are actually the graph we need. So I'm going to erase the red ones. Okay. So the blue graph is the graph of y equals square root of x plus 3. Alright, what's its domain? Okay, alright, it was shifted to the left 3. So instead of starting at x equals 0, we're going to start the graph at x equals -3. Okay, put a bracket there, it does start there. And as it goes to the right, we get answers. Okay, the range. Now the range would be similar to that first example. This first point has a value of 0. That one has a answer of 1. That one has an answer of 2, 3. Okay, so range, starting at 0, we actually get an answer of 0 to infinity. Interval of increase. Okay. Alright, we're starting at -3. So I'm going to write a -3. I'm going to write infinity. But just like on the previous example, I'm going to put a parenthesis here because technically at -3, at that very instant you start, it's going at a vertical slope. So I'm going to put a parenthesis there. Interval of decrease, as you go to the right, it never goes down. X-intercept, that's at -3. Y-intercept, now the y-intercept is a little more interesting here because this red point would be where it crossed the y-axis, and we don't have an exact value there because it doesn't go through exactly one of the corners on this graph. So I can't really tell graphically what the y-intercept is, but we can find algebraically very easily. Okay, by an algebraic way. To find the y-intercept, you let x equals 0 in the function. So we go up to that function, which is y equals square root of x plus 3, and we make x 0. So we get square root of 0 plus 3. 0 plus 3 is 3. The square root of 3, okay, is approximately 1.732. So I'm going to write my answer as a square root of 3. So if you're not used to that, it's okay. Um, we don't always have to have a decimal. We can write just um, what the decimal would be instead of writing 1.732. It's okay to write square root of 3. Okay, and let's see the right hand behavior. The same as the last example. Go to right, it sweeps up. So we're going to say as x approaches positive infinity, y also approaches positive infinity. Just like the last example, we're going to say none. Alright, next function we're going to do is y equals, looks almost the same, but I'm going to put the plus 3 behind the radical sign. So in this case, the plus 3 is not grouped with the x. So that means that's a shift up. That's a shift up 3. Whereas if the x plus the plus 3 was within the radical sign, that would be a shift of left 3. So we're doing up 3 this time. So I'm going to start out with the basic function. So it's really, if you practice these, you really won't have to draw these points every single time. But practice, you'll be able to. So I'm going to shift 0, 0 up 3. First point, shift 1, 1 up 3, shift the next point up 3, shift the next point up 3, draw my graph. Okay? Alright, erase my points. Okay? Alright, domain. Okay, don't make sure on domain you look and go down the x-axis. At 0 we substitute 0, we substituted 1, we substituted 4, we substituted 9. And again, we could have, when we substitute 3, we could have got an answer. It would have been square root of 3. It's just not as convenient. It's more convenient to pick our perfect squares to do square roots. So our domain starts at x equals 0 and any number, positive number greater than 0. Range, we'll look at the answers, take your time. Okay, the height of this point right here, I'll make it red, is this time it's 3. The height of this point is 4. The height of this point is 5. That one's 6. And in between 3 and 4 we get answers. Between 4 and 5 we get answers. Between 5 and 6 we get answers. Between above 6 we get answers. But the lowest answer we can get in this with this function is 3. So it's 3 to infinity. Okay, answers. Okay, those are answers. Okay, interval of increase. Alright, starting at y equals 0, x equals 0, excuse me, x equals 0. I'll put a parenthesis around there. Like I explained in the last two problems, at 0 technically the slope is undefined. Okay, it's one of those kind of almost trivial things, but for calculus students it'd be fairly important. Interval of decrease, none. X-intercept. Well, this curve never gets low enough to touch the x-axis, so it has no x-intercept. Y-intercept, we should always have a y-intercept when we have a function. The y-intercept is the y value, touch the y-axis, and that's at 3. The right-hand behavior is similar to the other two examples. And it doesn't go to the left forever, so I'm going to say no left-hand behavior. Okay, so logically, next thing we're probably going to do, since we've been increasing forever, we're going to go ahead and do this, and probably by this time you're going to see. Put a negative in front of a function, it's going to reflect it across the x-axis. And that's exactly what's going to happen here. Reflect across x-axis. Okay? So here's our parent function. The red points would represent y equal positive square root of x. So we're going to reflect that across the x-axis. So this point at 0, 0 is not going to reflect across the x-axis because it's actually on it. It's going to just stay there. But the next point at 1, 1 is one block above the x-axis. So I'm going to go one block below the x-axis and put the same dot, but put it down below. Alright, the same thing with the next point at 4, 2. Okay, that has a gap of 2 blocks above the x-axis. So I'll go 2 blocks below, put a point, and then at 9, 3 I'll do 9, negative 3. So the blue graph is the graph we're interested in. That's the graph of negative square root of x. Domain. Starting at 0 and any positive number we can plug in. The range, okay, can be confused, students. This answer is 0 if you take the time. Just look. This answer was from a negative 1. This answer from that y coordinate of that's a negative 2. The y coordinate of this dot point is negative 3. So it keeps going. I can get, if I extend that graph, we can get an answer of negative 4, negative 5. Now, when you do range, you start with the lowest answer you can get. Negative 4, negative 5, negative 6. I can find any negative number I want. This keeps getting larger, so I start with negative infinity. It's very important you put these in the right order. Okay, and the highest answer I get is 0. Put a bracket there. Alright, so let's talk about interval of increase or decrease. Let's see if it actually does increase. Okay, you go to the right. As you go to the right, it's going downhill. Going down. You're walking like down a hill. So it's not increasing. It's decreasing, starting at x equals 0 to infinity. Always a parenthesis around infinity sign. There's nothing to think about there. At the 0, it's actually going to be at very instant of 0. It's going to have a undefined slope. So we're going to say we use a parenthesis there instead of a bracket. X-intercept. Okay, at x equals 0, we have crosses there, across the y-axis at 0. Alright, now the right-hand behavior is going to be different on this problem because as we go to the right, it just sweeps down. You can see it. So when that happens, you say it's still going to the right. As we're going to the right, that's what that means. This time the graph will go down. It goes down very, very slowly, but it'll go down forever because it goes to the right forever. As it goes to the right forever, it goes down. It'll go down forever. Lift in. Done. Okay, the last example, I'm going to do this. We've done a bunch of square roots. There's other kind of roots. Okay, this one is called the cube root because that 3 is cube. And we can do all kinds, we can investigate all kinds of other roots. 4th root, 5th root, your 10th root. You can pick any number you want. Okay, so we're not going to investigate all of those. There's some similarities. There are similarities between roots that have even indexes, like index is just this number right there. That 4 in that one, that 10 in that one. The index here is 5, which means that's an odd root. The index on this one we're going to do is 3, which is an odd root, and this one which we call the square root. That little index of 2 is understood. We don't ever write that there, but that is actually an even function. So I'm going to explain, the difference between odd roots and even roots just a second. So we're going to start out and substitute 0. Okay, let me get these other roots off. Alright, cube root of x. Okay, so the cube root of 0. Okay, technically means this. Since our index is 3, I'm thinking of 3 numbers that I have to multiply to make the number inside. And that the 3 numbers, those 3 blanks I put in those, the number I put in those 3 blanks, all have to be the same. Okay, so I can get it by doing 0, 0, 0. So the cube root of 0 is 0. Okay, cube root of 0 is 0. So when I substitute in 0, I get an answer 0. 0, 0 is a point on this graph. Okay, next thing I want to substitute is a positive 1. Really the same, almost, it's going to be a little bit like the square root. Substitute 1. And I pick a thing because I know it's going to work out nice. Cube root of 1. Okay, of course you can put this in a calculator. You can press 1, press your power button, and then 1/3. Okay, and group the 1 divided by 3 and press enter, and it'll tell you the answer. Okay, alright, definition wise, cube root means what 3 numbers that are the same multiplied equal 1. What do I put in those 3 blanks? Well, positive 1, positive 1, positive 1. So the cube root of 1 is 1. So when I substitute into that function 1, I get an answer 1. So, same, I get 1, 1 is one of my answers. Now, the next point I'm going to pick is actually going to skip quite a bit of numbers. I'm going to skip all the way to 8. I'm going to avoid picking x equal 2, x equal 3, x equal 4. They do have answers, but they're just not as handy to graph. So I'm going to substitute 8. Cube root of 8. Again, a calculator would tell you the answer. 8 with the power of parentheses 1 divided by 3. You have to use a parentheses for it to calculate correctly. It'll tell you it's positive 2. Okay, I like to talk about the definition. What 3 numbers, because it's cube root. If it is 4 through, it'd be 4 numbers. What 3 numbers exactly the same will multiply to make an 8. Well, 2 times 2 is 4, times 2 is 8. All 3 of those 2's are the same. So the cube root of 8 is 2. So when I substitute in 8, I get in 2. So I go way over here to the right at 8. I have 9 blocks to the right, so I just go 8 to the right, go up 2. Alright, there's a third dot. Now, the thing about odd roots like cube roots or fifth roots, we can actually substitute in negative numbers. So I'm actually going to use a negative 1 this time. I'm going to substitute in a negative 1. The cube root of negative 1. And again, if you use a calculator, it'll do it correctly. Make sure if you use a calculator, you put the negative 1 in parentheses. Alright, the power button. Okay, 1 divided by 3 in parentheses. Press enter. You get your right answer. But let's think about it this way. 3 numbers that are exactly the same that multiply to make it negative 1. Well, 1, 1, 1 doesn't work this time because positive 1 times positive 1 times positive 1 is a positive 1, not negative 1. But what we can do is make all these negative ones, and it'll work. The first 2 negative ones multiply to make a positive 1, and then that answer times the last negative 1 makes a negative 1. And all 3 of these negative ones are the same. So the cube root of negative 1 is negative 1. Substitute in negative 1, I get negative 1. So my next point is negative 1, negative 1, right there. The last point I'm going to pick is negative 8. Last number I'm going to substitute is negative 8. Okay, the cube root of negative 8 what three numbers multiply to make a -8? -2, -2, -2. So the cube root of -8 is -2. You substitute in -8, you got an answer of -2. So on the x-axis go left 8, on the y-axis go down 2, and there's your last point. Now, of course, we can substitute in 27, the cubic numbers, but they won't fit on here. So I'll just stop at those. So drawing the curve. Okay, let me try that again. Goes up very, very slowly. Okay, and that's what your curve is. All right, what is the domain and range? Okay, the domain was it. We picked negative numbers, we picked positive numbers, we picked 0. All right, it's all real numbers this time. For cubic, the domain is all real numbers. Odd roots, all real numbers. Fifth root, seventh root. But even roots, it's always restricted from 0 to positive infinity. All right, the range, okay, might give us a little trouble if we don't think about it. This point over here has a y value of -2. Okay, this one has a y value of -1. This one a y value of 0. This one a y value of +1. This point has a y value of +2. So if you just not thinking beyond where this graph goes, you might say -2 to +2. But that would not be correct, because if we make this graph longer in the negative and positive directions, it'll get as low as -3, get as high as +3. It'll go as low as possible, as you can imagine, or as high. So just like the domain, the range is all real numbers. Alright, interval of increase. Okay, this can be tricky as well. So as we go into the right, you can see it's going up. What's going to happen at x equals 0 though? So I'm going to borrow my calculus hat for just a second. Won't be long. I'm going to change that cube root of x to an exponential form. Okay, and the derivative, you might as well know right now. You put that exponent in front, and then you subtract 1 from that exponent, you get a -2/3, and then the -2/3 means you drop that x to the denominator, and it's going to be the cube root of x squared. So when we plug in 0, we're going to have an undefined number. So again, at this one little spot right here, actually, it's going to have an undetermined slope. So I'm going to say the interval of increase is from -infinity until it gets to 0. But at that one spot of 0, it's not going to increase. But once it gets past 0, it increases. So that's a funny looking way of writing interval of increase, because it sure looks like it's increasing. But you're going to have to trust me for a little bit. As it gets to 0, it's not increasing, or the slope is just not defined. Okay, wait till you get to calculus. Alright, interval of decrease, clearly it's never decreasing. X-intercept touches the x-axis at 0, touches the y-axis at 0. The right-hand behavior. Okay, so as we go to the right, the graph sweeps up. So I'm going to write it as this way. As x approaches infinity, y approaches infinity. Okay, it goes up very, very slowly, but it goes up. Alright, left end. Alright, turn your little man around for left end behavior. It does have a left end this time. It's going left forever. Okay, as you go left, alright, the y answers are getting lower and lower. That means negative infinity. And that's all I really wanted to show you on um, root functions. Of course, we could investigate more, but that is the basics.